Unit 1, Arithmetic Sequence and Series. These are our objectives. 1. Generate and describe patterns. 2. Define the following terms: sequence, finite and infinite sequence, common difference, and arithmetic sequence. 3. Find the next few terms of a sequence as well as its general or nth term. 4. Tell whether a given sequence is arithmetic or not. 5. Determine the nth term of a given arithmetic sequence. Now, there's this Chinese proverb that's related to our topic sequence. It says, "The best time to plant a tree was 20 years ago. The second best time is now." But then now, this Chinese proverb has been updated. So now it says, "The best time to plant a tree was 10 years ago. The second best time is now." Well, considering what's happening to our environment, we should really start caring for it. Now, when you go check a dictionary or when you search in Google, this is what you'll see. So, sequence. This is how the word sequence is spelled and pronounced. So, sequence. Now, what is a sequence? The word sequence is a noun. One definition states that it is the order in which things happen or should happen. A second definition states that it's a group of things that come one after the other. Another definition states it's a part of a movie, television show, etc. that deals with one subject, action, or idea. Now, obviously, among these definitions, the second one relates well with our topic. So this one shows a mathematical definition of a sequence. Now, what is a mathematical sequence? A mathematical sequence is a set of elements ordered so that they can be labeled with the positive integers. Labeled meaning there is a one-to-one correspondence between the elements and the positive integers starting with 1. So when we say there's a one-to-one correspondence between the elements and the positive integers starting with 1, it's the idea that numbers correspond to specific quantities. For example, in playing a game, a player counts dots on the die and jumps 5 spaces on the board because 5 dots correspond in quantity to 5 jumps. Meaning, for every term number, there corresponds a value. So for example, the first term is 5, second term has a corresponding value which is 8, or a third term also has a corresponding value which is 12. Now let's try this exercise first. Find the next 3 terms of or in the given set of numbers. Now for the answers. In letter A, the next 3 terms are 11, 13, and 15. So in letter B, it's 16, 19, and 22. In letter C, it's 7 sixths, 8 sevenths, and 9 eighths. In letter D, it's 1 over 64, 1 over 128, and 1 over 256. In letter E, it's 6 over 7, 7 over 8, and 8 over 9. Now, how did you find those succeeding terms? Now, the sets of numbers in this activity are called sequences. Okay, so now I'd like you to answer activity 1.3. What is the pattern on page 8 of your learning package 2? Now, a sequence is a logical pattern or arrangement of values defined by a general term or nth term. It is a succession of numbers in a specified order. Now, take note that every element in a sequence is called a term. The general term is a rule that defines the sequence. So take note that the general term, nth term, rule, or formula, they are all one and the same. So a sequence is a function whose domain is the finite set containing the elements 1, 2, 3, and so on and so forth up to n, or the infinite set, the set containing the elements 1, 2, 3, and so on and so forth without end. Now, there are two kinds of sequences. We have the finite and the infinite sequence. Now, as opposed to an infinite sequence, a finite sequence has a last term. And the last term of a finite sequence is denoted by or represented by a sub n. So this is the last term of a finite sequence. So for example, a sequence has 5 terms. Then the last term of the sequence is a sub 5. A sub 5, that will also be your a sub n. Okay? Now, if your sequence, say for example, has 10 terms, then your last term for that sequence will be denoted by a sub 10. A sub 10 is also your a sub n. Okay? Now, what are the terms of a finite sequence? Now, you'll see here, the terms of a finite sequence are a sub 1, a sub 2, a sub 3, a sub 4, and so on and so forth. Then you have a sub n minus 2, a sub n minus 1, and then a sub n. Notice that a sub n here is the last term of your finite sequence. Whereas an infinite sequence is a sequence whose terms are continuous and they do not have a last term. An ellipsis or 3 dots, denoted by this symbol, at the end of any sequence signifies the continuity of the terms. So, the terms of an infinite sequence may be this: a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, and dot dot dot. So, you see these 3 dots here. This is an ellipsis. It means that this sequence does not have an end. Okay, meaning it's not discrete. It has no last term. That's why it's infinite sequence. Now let's look at this example. Here, your n, the value of n is from 1 to 5, as you can see here in this first row. That means that there are 5 terms. Okay? And then you have a of n here in the second row. You have a of n. This is read as a of n. So when n is 1, your a of n is 3. Now what does this mean? Again, when n is 1, a of n is 3. What does this mean? This means that the first term is 3. So this one is the term number and this 3 is the value of the term. Now when n is 2, a of n is equal to negative 1, which means that the second term is negative 1. So the third term here is 1.5, fourth term is 10, and the fifth term is pi. Okay? So therefore, what kind of sequence are we given here? This is an example of a finite sequence because it's discrete, meaning it has an end. It has a last term. The last term here, which is the fifth term, is pi. Okay, so again, this finite sequence has 5 terms, as you can see. N is from 1 to 5. Now we may use the notation a sub 1, a sub 2, a sub 3, and so on and so forth up to a sub n to denote a of 1, a of 2, a of 3, and so on and so forth up to a of n respectively. So meaning this 3 here is our a sub 1, the first term. Negative 1 here is your a sub 2, the second term. 1.5 is a sub 3, the third term. 10 is a sub 4, which is the fourth term. Pi is a sub 5, the last term, which is also our a sub n. Now, how about this example? What kind of sequence are we given here? Now, here you can see that on the fifth box, here, after the fourth term, there's an ellipsis. Okay? So that means that this sequence is an infinite sequence, meaning there's no last term. So there is no a sub n. This right here is an example of an infinite sequence where the general term, which is a sub n, is equal to 3n plus 1. Now let's proceed with finding the next few terms of a sequence given its general term. So in the examples that you will see here, you will be given the general term or the nth term, and then you will be asked to find the succeeding terms of the given sequence. Now let's try this example. Give the first 3 terms of the sequence given the general term. So the general term here is a sub n equals 3n plus 8. So this is the rule, this is the formula, this is the nth term, this is the general term. Okay. Now, take note that a sub 1 is our first term, a sub 2 is our second term, and a sub 3 is our third term. Now, to find a sub 1 or the first term, simply replace this n here in the general formula by 1. So you will have a sub 1 equals 3 times 1 plus 8 equals 11. So the first term is 11. Now the second term, which is denoted by a sub 2, will be equal to 3 times 2 plus 8, which is 14. How did we get this? By replacing this n here in the general term 3n plus 8 by 2. And the third term, which is denoted by a sub 3, will be equal to 3 times 3 plus 8, which is equal to 17. How did we get this? By replacing this n here by 3. Now let's have a drill. I'd like you to complete the given tables. So here you are given the general term or the nth term. So I'd like you to find the first three terms of the sequence. Now let's discuss the answers. So here, for number 1, the first term is 2. To get the first term, simply replace n here by 1. So 5 times 1 minus 3, that will be 2. The second term will be 7. So replace this n here by 2. So 5 times 2, that's 10 minus 3, that will give us 7. To get the third term here in number 1, replace n here by 3. So 5 times 3, that's 15 minus 3, that will give us 12. So for number 2, just do the same process to get the first three terms. So the first term here is negative 3. How did we get negative 3? Replace this n here, all the n's here in the general term by 1. So 1 squared plus 2 times 1 minus 6, that will be negative 3. To get the second term, replace all the n's here by 2. So 2 squared plus 2 times 2 minus 6, that will give us 2. To get the third term, okay, substitute 3 into all the n's here in the general term. So 3 squared plus 2 times 3 minus 6, that will give us 9. For number 3, the first term will be negative 8, second term is negative 9, and the third term is negative 10. Using the same procedure that we have done in numbers 1 and 2. Okay, so to find the terms of a sequence given the general term, you only need to substitute. Right? At this point, you may now answer activity 1.4 titled, "Can you find my terms?" on page 10 of your learning package 2. Now let's proceed with writing the general formula of a sequence given some of its terms. Now in the previous examples, you were asked to give the terms in a sequence given its general term. This time around, we will discuss how to find the nth term or the general term given the terms of a sequence. Okay? So write a general term for the following sequences. So number one, you have this sequence, 1, 2, 3, 4, dot, dot, dot. Now notice that our a sub 1 here is 1. The first term is 1. A sub 2 or the second term is 2. 3 is the third term denoted by a sub 3. 4 is the fourth term and that's denoted by a sub 4. Now take note that this 1, 2, 3, 4 are the values of the term. Okay? And this a sub 1, a sub 2, a sub 3, a sub 4 refers to the position or to the term number. So a sub 1 means first term, a sub 2 second term, a sub 3 third term, a sub 4 is the fourth term. Okay, so take note, these are the values of the term and these are the term numbers or the position of these values. So here we're given a sub 1 equals 1, a sub 2 equals 2, a sub 3 equals 3, and a sub 4 equals 4. Okay, but we can just use the first three terms here. Now notice how the subscript for the term number compares with the value of the term. So let's look at the subscripts and then let's compare it with the term numbers. So here the subscripts are this a sub 1, the subscript is 1, 2, 3. The term numbers are this 1, 2, 3. So the subscript as compared to the value of the term. So if the subscript is 1, the value of the term is 1. If the subscript is 2, the value of the term is also 2. If the subscript is 3, the value of the term is also 3. Now notice that the term number is just the same as the value of the term. Right? So the first term here is 1. Second term, the value is 2. Third term, the value is 3. Therefore, the nth or an nth or the general term here will be a sub n equals n. Since the subscript is just the same or equal to the value of the term. Diba? Subscript, this refers to the term number or the position. This one here is the value of the term. Since in this example, the subscripts are just equal to the value of the term, therefore our general term here will be a sub n equals n. Let's have another example. So we have the sequence 5, 10, 15, 20, dot, dot, dot. So the first term here is 5, that's denoted by a sub 1. Second term is 10, denoted by a sub 2. Third term is 15, denoted by a sub 3. And the fourth term is a sub 4. Okay, which is 20. So again, a sub 1 is equal to 5. Second term is 10. Third term, denoted by a sub 3, is 15. Okay. Now, let's compare the subscript for the term number again with the value of the term. So, the subscripts are 1, 2, 3. And then the values of the term are 5, 10, 15. Okay, so let's compare them. So, if the subscript is 1, the value of the term is 5. If the subscript is 2, the term is 10. If the subscript is 3, the value of the term is 15. So this refers to the value of the term, this to the subscript for the term number. Okay, meaning this is the position of these values. Now, what operation carried out on 3 produces 15? So what will you do with 3 to get a 15? Basically, that's the question. And once you found that operation, check whether it's also going to work for the other terms here. Now notice that we can multiply a term by 5 to get the value of the term. So if you multiply 3 by 5, you get 15. We check that with 2. 2 times 5 is also 10. 1 times 5 is 5. Therefore, the general term here, okay, as you can see, so the rule applies to all the terms, meaning we will multiply 5 to the subscript. Therefore, in this example, the general term will be a sub n equals 5n. This is the subscript. So the rule is you will just multiply it by 5. So a sub n equals 5n. Let's have this example. So we have 1, 4, 9, 16. So here our a sub 1 is 1. The first term is 1. Second term, which is a sub 2, is 4. Third term, which is a sub 3, is equal to 9. And the fourth term is 16. Okay. Now again, to find the general term, let's try comparing again the subscript for the term number with the value of the term. So let's compare. So if the subscript is 1, the value of the term is 1. If the subscript is 2, the value is 4. If the subscript is 3, the value is 9. If the subscript is 4, the value of the term is 16. Again, these are the values of the term. These are the subscripts for the term numbers. Now, ask yourself, what operation are you going to use with 4 to arrive at 16? Okay, so what operation carried out on 4 produces 16? And once you find it out, check whether that operation will also work for the other terms. So, you might guess, multiply 4 by 4. So, 4 times 4 is 16, yes. But, if you use that same process here, meaning if you multiply this 3 by 4, 3 times 4 will not give you a 9. Because 3 times 4 is 12. It's not equal to 9. Therefore, multiplying by 4 does not work in this example. If you try guessing again, you can consider squaring 4. So 4 squared is equal to 16, right? Now check that rule with all the other terms. So let's square 3. 3 squared is 9. Check. 2 squared is 4. Check. 1 squared is 1. So check. So when you check, you can see that squaring the term numbers produces the value of the terms. Okay, 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16. Therefore, what's the rule here? We will square n, the subscript. Therefore, the general term will be a sub n equals n squared. So the rule is you square the subscript. Okay? So that is our general term in this example. Now another example. We have 3579. So again, our first term is 3. That's denoted by a sub 1. So a sub 1 is 3. A sub 2 is 5. A sub 3 is 7. A sub 4 is 9. Now notice that here, you can easily recognize the pattern and find the next term in the sequence to be 11, right? 3, 5, 7, 9. You know that the next term here is 11. But finding the general term here may be a little more difficult. Okay, so what do we do? Again, let's try comparing the term number with the value of the term. So, term number is 1, the value is 3. Term number is 2, value is 5. Term number is 3, the value of the term is 7. Subscript is 4, the value of the term is 9. So again, these are the values of the terms, and these are the subscripts for the term number. So here we saw that a sub 4 is equal to 9, right? So ask yourself again, what operation do we do with 4 to produce 9 or to get a 9? So one guess might be you add 5 to 4. So 4 plus 5, yes, it's 9. Now let's check that with the other terms. 3 plus 5 is 8. It's not 7. Therefore, adding 5 will not work here. Okay. Now, if you guess again, so what can you do with 4 to get 9? So one possible answer is to multiply 4 by 2 and add 1. So 4 times 2 is 8 plus 1, that's equal to 9. Now let's try this with the other terms. So your a sub 3 is 7. Okay? So get this 3 subscript. 3 times 2 plus 1, 7. So check. Your second term is 5. So let's check. 2 times 2 plus 1 equals 5. Check. The first term is 3. Therefore, let's check. 1, the term number, times 2 plus 1, that is equal to 3. Therefore, the rule here is to multiply n, these are our n's, this 3, 2, and 1. So, multiply n by 2. So, n times 2, or that is 2n. Add 1, so plus 1. Therefore, the general term here will be a sub n equals 2n plus 1. Okay, so a sub n equals 2n plus 1. Again, where did we get this 2n? This is from 2 times your n, or your subscript. So 2 times n plus 1. That will be the general term in this example. Now let's try another example. So here you have 1/2, 2/3, 3/4, and 4/5. So again, a sub 1 here is 1/2. A sub 2 is 2/3. A sub 3 is 3/4, and A sub 4 is 4/5. Now let's just consider the first three terms. So what we can do is, let's again compare the term number with the value of the term. So term number, value 1/2. Term number 2, value 2/3. Term number 3, value is 3/4. And then, and then try to look for a pattern. So what pattern do you see here? Notice that the subscript, okay, or the term number is equal to the numerator here in the value. Okay. So notice that the term number is the same as the numerator here. Okay, and then the denominator, what happened? You add 1 to the numerator, you get the denominator. Now let's check this second one. The term number is 2, look. The numerator is also 2. Then you add 1 to 2, you get 3. Next, term number is 3, numerator is 3. To get the denominator, add 1 to 3. Okay? So that was the pattern that we found. Therefore, the general term now could be a sub n equals, the numerator is n, the same as the term number. So n over, how did we get the denominator? Add 1 to n plus 1. Alright? So the general term here is a sub n equals n over n plus 1. Now another example. Here we have 1, negative 1, 1, negative 1. So a sub 1 is 1, second term is negative 1, third term is 1 again, and fourth term is negative 1. So notice that here, the numbers 1 and negative 1, they just alternate from one term to the next, as you can see in the given. Now, if the subscript is odd, the term is 1. So if we look at the given here, if the subscript is odd, so 1, this is odd, the term is 1. If the subscript here is 3, which is odd, the term is also 1. Okay. If the subscript is even, the term is negative 1. So here, the subscript is 2, it's even. Therefore, the value of the term is negative 1. The subscript here is 4, it's also even. Therefore, the term is negative 1. The value of the term is negative 1. So, take note. Subscript is odd, term is 1. Subscript is even, the term is negative 1. So, here it's odd, so 1. Even, so negative 1. So, these are the values of the term. Okay. Now, one pattern recognized here is multiplication by negative 1. Thus, the first term is 1. If you multiply this by negative 1, you get negative 1 to obtain the second term, which is a sub 2. If you multiply this a sub 2 naman, the second term, by negative 1, you will get positive 1. Multiply this again by negative 1, you will get negative 1. Okay? And the process continues. Thus, a sub 1, which is equal to 1, will just be equal to negative 1 times negative 1 or negative 1 squared, which is 1. A sub 2 will be negative 1 times negative 1, this came from a sub 1, times negative 1, that will be negative 1 cube or negative 1. A sub 3, this came from a sub 2, so negative 1 times negative 1 times negative 1 times negative 1, that will be negative 1 to the fourth, which is positive 1. Therefore, negative 1 is a base, and the sequence can be expressed as a power of negative 1. So, look what happened here. If your term number is 1, What is the power? Negative 1 is constant. It's the base. The base is always negative 1. But look at the power. If it's 1, if the subscript is 1, the power is 2. How do we get 2 from 1? That is just 1 plus 1. So n plus 1. Therefore, the general term here could be a sub n equals negative 1, the base, raised to the power n plus 1. Okay. Now, I'd like you to answer activity 1.5, what is my formula, which is found on page 12 of your learning package 2.